Hi folks, welcome back to 6.1 Area Between Curves. We're going to take a look at the practice example number 4. So this question says find the area of the region bounded between the graphs of f of x equals 6 minus x squared and g of x equals negative 2x plus 3. Now I know that the g of x function is a line because it's just a y equals mx plus b form. And it's really important that you're able to recognize that, okay? So I know that the g of x is the line in the blue. The f of x is our 6 minus x squared, which means that we should also know that it's an upside down parabola, okay? Both of these functions would be completely fair game to ask you to do without technology. So let's go ahead and set up our area formula. We're going to use our graph to find our bounds, and then we're going to show that we know how to find those bounds algebraically as well. So the area formula is the area equals the integral from a to b of the top curve minus the bottom curve. And it's really important that we put a dx here. And what we're going to take a look at here is the area that is between these two curves. So that's going to be this region right here. All right, and the green, that is the area that we are trying to find. So knowing that, let's identify our A, or our bottom bound, and if we look all the way at the x-axis, that's going to be negative 1. And let's look at our top bound, which is going to be this value, or if I bring it back to the x-axis, it's going to be 3. So we're looking at x values here, and that's actually really important because these values need to match the dx, okay? So if I have a dx at the end, I better have x values as my bounds. All right, so let's plug this in. We get the integral from negative 1 to 3 of the top curve, which is 6 minus x squared, minus negative 2x plus 3, which is the bottom curve. All right, and the reason why we're doing top curve minus bottom curve is we're trying to find this distance between the top curve and the bottom curve. And if I drew an infinite number of little skinny black lines like that, then that would equal the area of the green part. So let's go ahead and find our bounds algebraically before we finish finding our area. That means we're going to take 6 minus x squared. We're going to set it equal to negative 2x plus 3. Now, since I see a quadratic, I'm going to go ahead and move everything to one side, set it equal to 0. So I get x squared minus 2x, and then 3 minus 6 is minus 3. And that factors, as it should, into x plus 1 and x minus 3. And when I do x plus 1 equals 0, I get x equals negative 1, which makes sense because that was my a value, or my lower bound. Then I have x minus 3 equals 0, or x equals 3. And that gives us our b value, or our top bound. All right, so again, this process is really important that you're able to do all these parts even though you have a graph available. So let's go back to our area function and let's simplify this before we take an integral. So the integral from negative 1 to 3 of 6 minus x squared plus 2x minus 3 dx. And we're able to combine some like terms. So I'm going to move that negative x squared to the front, plus 2x, and then 6 minus 3 is a plus 3 dx. And now I'm going to find my antiderivative. So the first part is going to be negative 1/3 x cubed using the power rule, plus the integral of 2x is x squared, plus the integral of 3 is 3x. Draw the line, 3 and negative 1. Now I'm going to continue this down here so we have a little bit more room to write horizontally, but I'm going to plug in my 3 first. So 1/3 3 cubed plus 3 squared plus 3 times 3 minus negative 1/3 times negative 1 cubed plus negative 1 squared plus 3 times negative 1. All right, let's clean this up a little bit. So in the first term here, I've got negative 27 over 3. Now I'm intentionally not simplifying because I notice that this and this I can combine as like terms in a little bit. Plus 9 plus 9, all right, minus, let's take this next part step by step so we don't mess up any signs. The negative 1/3 times the negative 1 is going to be a positive 1/3 plus 1 minus 3. Now we can distribute this minus sign to everything in here. So negative 27/3 plus 18 minus 1/3 minus 1 plus 3 is going to give me negative 28/3 plus 18 minus 1 is 17 plus 3 is 20. And now I can combine these into a single fraction. And what am I going to get? 60 minus 28 will give me 32 over 3. All right, so let's zoom back out so you can see the whole page on one screen. And here's our work for question number 4. And we found that the area of that green part is 32 over 3. All right, folks, come on back. We've got 4 more examples that we're going to go through, and hopefully this will be making things clearer for you to find area between curves.